Hello everyone, how are you guys doing? I hope you're all doing amazing. Welcome to the second part of the series where we are solving the top interview 150 questions from LeetCode using Golang. Now, and today we will be solving the second question of this study plan, which is remove element. Now, in this problem, which I hope you have already read, we are given an array nums and an integer value val, and we have to remove all occurrences of val from nums in place. Now, again, we have to somehow use the concepts we have generalized from the previous video to actually solve this problem, because this is again a in place update kind of a problem, and we did that in the last video. If you have not seen that, go back, just watch the video already. What are you doing? We have made a series for a reason. A sequence, it needs to be followed in order. Well, enough of me blabbering. Let's start by solving this problem. So let's take in an example that has been given to us till now. So let's say this is the example, which is 3223 and the value is 3. So finally, we don't care about what you fill in the last values of this new array, and you just want to return the nums values. So to do that, let's try to understand how we can actually go about solving this problem. So let's take a bigger example. Let's take the second one for that instance, which is 01223042. And the value is 2, 01223042. I hope my memory works after all the reels I've been scrolling recently. 0122 4032.
Games that you had you could you do.
Yeah, I need to stop those reels. So this is your array, and you have a value which is equal to 2. That I remembered. And you basically want to remove all of the occurrences of 2 from this array and actually get a new array where your first elements are all of the elements from this array that doesn't have 2 in it, and we do not care about your final values that are left in the array anymore, which were removed because there was 2 in it. And also I think you need to return your final k. So yeah, we also need to return what is the final length of the string that we expect the judge to finally check it. So yeah, that's our problem. Let's try to use the concept we did in the previous video, where we first try to visualize what the output will look like from this. So if we run this through our function, it should finally return 0, 1, p, 0, 4, and there should be p values which don't have anything in them, or have anything in them. That's the whole point. So how can we do about that? So basically, what we have to do is, whenever we encounter a value that is not equal to 2, we don't have to worry about anything. We just have to let it be where it is. But in cases where there is a 2 in between, that value has actually shifted to the position. So how can we do about that? So remember in the last video how we used an third variable to actually make our problem simpler by handling what we need to traverse through at the point. I think something similar can work for this. But in this case, instead of going through from the last because we are scared of override, we are okay with override because we don't care about values that have 2 in them, and we can actually override them as we did with these indexes. And anything after the index that is there, we don't worry about it because that's our final length that we return, and the judge of the problem is only going to check these values. So to solve that, we basically introduce a third variable k, which starts at 0, and it will only increment if we come across a value which is not equal to 2. And whenever it comes across a value that is equal to 2, it just doesn't increment. So by doing that, we'll keep the pointer here as we are traversing. Again, when we encounter 2, we'll keep the pointer at this exact same location, and when we finally reach a 3, we fill in the value 3 in it and move the pointer forward. So in some sense, what we are doing is, if we try to do a dry run of the algorithm, we basically are trying to traverse through these values and filling in the value on the basis of its comparison with the val that is to be removed. So let's just do that. So your pointer starts at 0, you are at this position, you see that your value is not equal to 2, so you fill in that value, and at the same time you increment your pointer. Now again your value is not equal to 2, so you fill in that value and then you increment your pointer. Now your value is equal to 2, so you don't increment your pointer and you don't fill in anything. Now again, when you are here, your pointer is not equal to 2. Your pointer is equal to 2 and you again don't want to increment your pointer. And finally, when you reach 3, that is where you have finally reached a value that is not equal to 3. So your pointer still points at this position, which you will fill in with the value you have just received, and then you will finally increment the position of your pointer. And that's how your loop will go. So in that sense, you will be overwriting any value that is equal to 2, and at the same time, you will not worry about anything that happens after these values that don't have 2 in them, because they can be any value, no one is going to check them. So I hope this logic made sense. In some sense, we are following the same concepts we formed in the previous video, where we try to use a third variable that can simplify the traversal for us. So we have something we need to traverse through, that is to be traversed through, that is fixed by the problem. In the previous problem also, what we tried to do was first find a variable we actually need to traverse, find what to traverse. So I think this is more of a array specific thing, and I don't want to write the whole thing down, so I'll just be a bit quickly with that. So basically, you find your I, because we mostly write for I in range in Python. So if you are coming from a Python background like me, you understand that for find I is basically finding what you need to traverse on. Then you basically find your helper variable, and then you have a behavior on the basis of what your helper variable is and what your I is right now. So I hope this generalization makes sense. In some sense, what we are trying to do is we are trying to break the problem into simpler steps, where we are first trying to observe what all elements we need to look into to solve this problem. So when we looked at this problem, it was very clear that we have to compare each of the value with 2 and see if it needs to be filled in or not. So that was the first parameter that we have found our I, which is that we need to traverse through whole array. The second part is trying to understand that what variable can actually help me fill in these values, and for us it was k, and we understood that we need to increment k on the basis of the element and its comparison with val, because we are okay with overwriting values. So we understood what behavior the helper needs to follow behavior, and why is it different from our traversal behavior, because if we were just traversing and doing some update, then the problem is even simpler than a LeetCode easy problem. That's not what you will be asked in any interview. I think these are the concepts we can generalize from this and the previous problem together. And let's just finally get into coding this. So we understood that we'll be traversing on our nums. So we can try to instantiate it the way we discussed previously. So you can have a I that you instantiate right here. In the second block, you will decide that it should be less than len nums, and it should go by 1 every time. And inside of this loop, but before that, you have to also maintain a third helper variable. Let's call it just helper to reinforce the concept. So your helper is at 0. And when you are traversing this array, you basically want to check if nums I is equal to val. If it is equal to val, then you don't do anything. So I think it's better to write the code when it is not equal to val. So when your nums I is not equal to val, you want to fill in your nums helper with your nums I, whatever value you are at right now, and at the same time you'll increment your helper so that now you fill in the next index and don't override the value which is not equal to 2. If that's not the case, if your value is indeed equal to 2, you don't want to do anything. That's what we just said. So your else condition is just going to be empty. So it's better not to just write else altogether. Missing return. What did we need to return? Oh, I completely forgot. We also have to return k. So yeah, Always read your problems and don't try to be overconfident that you remember them from the last time you solved them. Help not. Help not. Just return helper. Yeah, that should be it. Let's run this. And we'll not be forgetting to submit this time. Can't do the same mistake twice. Let's just submit. Wow, taking a lot of time. Yay! So again, we beat 100% in runtime and 99.4% in memory. Oh my god! Don't be too overwhelmed by these LeetCode runtimes and memory. They are just stupid. Just see if your code is getting submitted or not, and it's not hitting TLE, which is time limit exceeded. So yeah, no new Golang concepts to learn from this problem, except we use the for loop, proper for loop in this one, and in the previous problem we used for loop as a while loop. But yeah, that's pretty much it. See you in the next video. Bye bye.